All right, so for today's third system of equations lesson, we're going to talk about solving a system by elimination. So what does this mean? This means that we're actually going to find one set of opposite coefficients that we can eliminate in order to solve for one variable. So I feel like the key word that you need to remember that elimination means is that you are going to use, or you're going to be using, opposite coefficients. And this can obviously be for either x or y. I tend to get rid of x to eliminate a variable. So we're still looking to find a solution with an ordered pair, but we have to do that a little bit differently with elimination. So I'm going to do the first example, and then we're going to talk about the steps. So I can see that I have two linear equations and that I want to solve for the ordered pair x, y. Now, I'm betting to guess that most of you will be like, well, I can solve for y and use substitution. But if you're told to use elimination, you actually do have to use this method. So I can see that between 4x and 2x, they have factors of 2 and 4 in common. So when I use elimination, I can take a -2 and I can multiply it through the entire equation, and it is going to give me -4x plus 6y equals -16. And what that allows me to do is it allows me to actually add or subtract these equations together. It's kind of mentioned up here at the top, in order to get rid of x. So when I write that out, I always rewrite my two equations. First one I did nothing with. The second one, I'm going to write every term below the term it's with. And that allows my x's to go away, because 4x minus x is 0. 3y plus 6y is 9. And 16 minus 16 is 0. I divide both sides of this by 9, and I get 0 divided by 9, which is 0. So now I know my y value. I can go back and I can input it into either equation. I'm going to choose the all positive equation, and I'm going to do 4x plus 3 times 0 for that y value equals 16. 4x equals 16. And when I divide by 4 on both sides, I get x is equal to 4. So my solution set is 4, 0 for this system of equations. Now, a lot of you might be asking, how did I know to multiply by the -2 towards the bottom equation and not multiply the top by something? I typically just look at my x values and I decide by knowing my math facts, like which one is going to get my x to 0. That means I know I need to get a -4, so in order to get 2 to -4, I have to multiply by 2. So let's try another one together. Looking at this next one, I can see I have both at 1x, and then I have a 3y and a -4y. So if I want to go about eliminating my x, if I added those together right now, I would get 2x. So what I'm going to do is I know I can multiply this equation by -1. That will give me my -x, it will give me positive 4y, and it will give me -11. Now I can put these equations one by another, and my x's should subtract or add out to be 0. If they don't, that means you've done something in your distribution of that number with multiplication wrong. So there, these x's now equal 0. This equals 7y. This equals -14. I can solve for y by dividing by 7, and I get y is equal to -2. I can take that -2 and I can put it in any of the original equations. So I'm going to put it in the top one. So x plus 3 times -2 equals -3. X minus 6 equals -3. Add 6 to both sides, and I get x is equal to 3. So my solution set is 3, negative 2. So really this is about decision making in order to eliminate the variable. Let's take a look at example 3. In example 3, I can already see when I put these together, my 3x's are going to go away. So I don't need to multiply a number through the equation. I can just go ahead and put these together. So that gives me my 0. Y plus 4y is 5y. Negative 8 plus negative 2 is negative 10. I can divide by 5 on both sides to get y is equal to negative 2. I can then take that y equals negative 2 and import it back in to the equation. I get 3x is equal to negative 6. Divide by 3. X is equal to negative 2. So my solution for this is negative 2, negative 2. So in some cases, you don't actually have to eliminate. You just need to add or subtract the equations together, and it will eliminate automatically for you. But in other cases, you do need to distribute a number through one of the equations to get the opposite coefficient. So I feel like you need to put in your steps. The biggest thing to remember is, I like to do the x variable, but you don't have to, is that you need opposite coefficients for either x or y. And in all those examples, I did it for x. The next step that you would do is you would add or subtract your equations together after you get that opposite coefficient. You would then solve for one variable. So I solved for y, and then you would use substituting and solve for x. All right, so I'm gonna do 3 more practice problems. Sorry, I'm looking through my notes. Let's go down here and look at the mixed up variable ones. So what we mean by mixed up variables is we don't have those equations in the same format. So we want to do that before we try to do elimination with them. So in this very first example, in order to make it in the same format, I need to bring the y back over to the left so that the top equation and the bottom equation match. So if I do that, that 5x is going to stay, but the y is going to come over, so we know it'll be a plus y equals negative 3. And then the other equation is already in that format, so I can leave it. So I can see here I do not have any opposite coefficients. And this, in some cases, might be easier for you to do the opposite coefficient by pushing through an 8 to make it an 8y and a negative 8y and solve for x. Because in this one, if you want to get rid of your x's, you're going to have to multiply both equations by a number to change the x's, because 5 and 3 only have 15 in common. So the top equation would have had to be multiplied by 3. And the bottom equation would need to be multiplied by 5. So to save yourself some work, you can actually just push a positive 8 through the top. That'll give you negative 40x plus 8y equals negative 24. And you can automatically see that in these two equations, with the change, that the 8's are opposite coefficients. And I can go about solving for x in this case. So I get negative 37x, the y's go away, so these go to 0, and then I get a 0 over here. I divide by negative 37 on both sides, which leaves me with x is equal to 0. I plug the x back in, and I'm actually gonna, it doesn't matter which one you plug it back into. Let's just do negative 5 times x equals negative 3 minus y That gives us 0 equals negative 3 minus y. When I add 3 to both sides, it gives me negative y equals 3. So that means y is negative 3. So my solution set for this equation, I'm going to write it up top. I kind of ran out of room, is 0, negative 3. All right, let's take a look at the next one. So we can see they're automatically, both equations are not in the correct format. So on this first one, I'm going to take the negative 3y and pull it back over here. So negative 3x plus 3y equals 3. And then in the bottom one, the negative y needs to come over and the negative 13 needs to go to the other side. I'm not really showing this as my work. I'm just doing the opposites as if you were solving. So that y is going to come over here as a plus. The 13 is going to come over as a plus. And again, I can see that it's much easier to multiply this bottom equation by negative 3 if I have a positive 3y right here. So that leaves me with 15x minus 3y equals negative 39. And I'm going to rewrite the equation below it so that it doesn't look as confusing. So the original was negative 3x plus 3y equals 3. And then I'm going to put these two together. So that gives me 12x. Those go to 0. This goes to negative 36. And notice my numbers are fairly user-friendly. X is negative 3. I need to now solve for y by putting my numbers back into one of the equations. I'm going to go with the top one, 3 minus 3 times negative 3. That whole right side is going to give me 12. And when I divide by 3, I get x is negative 4. Oops, sorry, that should be... I did that wrong. So let's go back. See, I accidentally made the mistake of putting my variable in. I'm so used to putting it in for y. This should actually be negative 3 times negative 3. Sorry, I input my x value in for y. So this is 9 equals 3 minus 3y. This gives me 6 is negative 3y. And when I divide by negative 3, I get y is equal to negative 2. So my solution is negative 3, negative 2. All right, last one we're going to do together. So this one, you have the option you need to move both of them again. So we're going to put it in that format. We're going to bring over the 5y. So 6x minus 5y equals 12. And then we need to do that double switch with the y and the negative 20 to get 2x plus y equals 20. And then I make my decision on which variable to eliminate. I'm actually going to go back to eliminating my x to show that you can go either way. So if I multiply this entire equation by negative 3, it's going to make my x's go away. So that'll give me negative 6x minus 3y equals negative 60. My other equation was 6x minus 5y equals 12, and I'm going to put those two together, eliminating my x variable to 0. That gives me negative 8y. This gives me negative 48. And when I divide by negative 8, I get y is equal to 6. Again, I'm going to plug that 6 back in for y. So I get 6x equals 12 plus 5 times y. 6x equals, that's 30 plus 12 is 42. I did that all in one step, and x is equal to 7. So my solution set is 7, 6. All right, so if you need to pause and rewatch, do that. But in summary, you should always have an opposite coefficient. And the steps you take are everything needs to be in the same format. So I'd do my x term, my y term, and my whole number on the other side of the equal sign. In step 2, you decide which opposite coefficient are you going to clear out to 0. Distribute that number. clear the coefficient. So in most of these I did x, but in the numbers 1 and 2 here on the bottom I did y. Solve for the first variable, and then substitute to solve for the second variable using one of the original equations. We are going to go over this again tomorrow in class. So as long as these notes are taken, go ahead and try your check for